You walk out to the garden on a Tuesday morning in July and something has changed. The new growth on your pepper plants, the young tender leaves that were opening just days ago, is curled, deformed, and sticky to the touch. You turn a leaf over, and the underside is coated in them. Tiny green bodies, clustered so densely they look like a living carpet. Aphids. Thousands of them, multiplying faster than you can process what you are seeing. You check the tomato plants next, worse than the peppers. The stems are coated. Ants are climbing up and down, farming the aphids for the sugary honeydew they excrete. That honeydew is growing black sooty mold on the leaves below. The plants you spent months nurturing from seed are being drained in real time. You move to the cucumber vines and find something different. The leaves are pale, stippled with thousands of tiny yellow dots, as if someone had painted them with a pin. You turn a leaf over and see delicate webbing between the veins. Spider mites. You can barely see them. Specks moving on the undersides, some red, some clear, multiplying invisibly until the damage becomes obvious. And when you shake a zucchini leaf, a cloud of small white insects rises up like dust and settles back down a few seconds later. Whiteflies. They have been there for days, and you never noticed because they hide on leaf undersides during daylight. 3 different pests. 3 different problems. One garden being actively destroyed in front of you. And the easy solution, the one every hardware store sells in bright plastic bottles, is exactly what you have been trying to avoid. You grow vegetables because you want to know what is in them. You are not going to spray synthetic pesticides on the food you are about to put on your family's plates. But watching the plants deteriorate while you figure out what to do is not an option either. There is a solution. A simple one. Sitting in your kitchen right now, 3 or 4 ingredients you already own, mixed in the right proportions and applied the right way, will kill aphids, spider mites, and whiteflies on contact. Without synthetic chemicals, without harming the beneficial insects your garden depends on, and without leaving residues on the vegetables you are about to harvest. The formula is not a secret. It has been used by organic growers for decades and backed by research from multiple universities. But most gardeners who try homemade pesticides get 1 or 2 details wrong and end up with a spray that either does not work or damages the plants it was supposed to protect. I'm going to walk through the actual science of why soap, oil, garlic, and pepper are effective against soft-bodied garden pests, the 3 specific formulas for different pest situations, the application technique that determines whether you succeed or fail, and the mistakes that turn a powerful DIY insecticide into a waste of time. By the end of this video, you will have a complete pest control system using ingredients that cost less than $1 per gallon of finished spray. But first, you need to understand what makes aphids, spider mites, and whiteflies vulnerable to kitchen ingredients, because the mechanism explains exactly why the formulas work and why certain mistakes ruin them. All 3 pests share a common physical weakness. They are soft-bodied or small-bodied creatures that rely on a thin, protective outer layer, a waxy cuticle, to hold moisture inside their bodies. Unlike hard-shelled insects such as beetles, aphids, and whiteflies have essentially no armor. Their entire survival depends on that waxy coating, preventing them from drying out. Spider mites, though technically arachnids rather than insects, share the same fundamental vulnerability. Their tiny bodies lose moisture rapidly when the protective layer is compromised. This is where dish soap becomes a weapon. Soap is a surfactant, a compound that breaks down the barrier between water and oil. When you spray a soap solution onto an aphid, the soap dissolves the waxy coating on the insect's body. Within seconds, moisture starts evaporating out of the insect through the damaged cuticle. The aphid cannot regulate water loss. It desiccates. It dies. This is not a toxic poisoning mechanism. It is a physical destruction of the insect's ability to stay hydrated, which means soap cannot be resisted the way insects develop resistance to chemical pesticides. The mechanism is too fundamental to be genetically outmaneuvered. Research at Cornell University, USDA agricultural stations, and university extension programs across North America has consistently documented insecticidal soap achieving over 90% kill rates on aphids, whiteflies, spider mites, mealybugs, scale insects, and thrips at the correct concentration. The key words are correct concentration. Too weak and you fail to dissolve the cuticle. Too strong and you damage the plant along with the insect. The sweet spot is 1 to 2% soap by volume. 1 to 2 tablespoons of dish soap per gallon of water. Higher concentrations cause leaf burn. Lower concentrations allow the pests to survive and repopulate within days. The type of soap matters. Use a plain, unscented liquid dish soap without added moisturizers, antibacterial agents, degreasers, or bleach. Dawn Original, Ivory, or any basic unscented dish soap works. Do not use detergent labeled for dishwashers. Do not use soap with added skin conditioners. Do not use antibacterial hand soap. The added chemicals in specialty formulations can cause phytotoxicity, visible leaf damage that looks like burning or yellowing within hours of application. Plain unscented dish soap is the only reliable choice, and it costs $2 to $3 for a bottle that will make dozens of gallons of spray. Oil adds a second mechanism that works especially well against spider mites and scale insects. When fine oil droplets coat an insect's body, they physically block the tiny breathing pores, called spiracles, through which the insect exchanges air with its environment. The insect suffocates. Oil also smothers insect eggs laid on leaf surfaces, preventing the next generation from hatching. This is particularly important for spider mites, which reproduce so rapidly that killing only the adults gives you a week of relief before a new wave of hatching eggs restarts the infestation. Oil kills both stages simultaneously. Vegetable oil from any grocery store works. Canola, soybean, or sunflower oil are the most commonly used. Neem oil, sold at garden centers, adds a second active mechanism on top of suffocation. Azadirachtin, a natural compound that disrupts insect hormone systems and reduces feeding and reproduction. For serious infestations on plants that tolerate it, neem oil is genuinely effective. For general use on a wider range of plants, basic vegetable oil from your pantry provides the suffocation effect at a fraction of the cost. Garlic and hot pepper play a supporting role rather than a primary one. Both contain compounds that irritate insects and discourage feeding. Allicin from garlic, capsaicin from hot peppers. They do not kill on contact the way soap and oil do, but they repel new pests from colonizing treated plants and can disrupt feeding on existing populations. Adding garlic and pepper to a soap and oil spray broadens the effect, killing the pests already on the plant while discouraging new ones from landing. 3 ingredients, 3 mechanisms, each one addressing a different vulnerability. Combined correctly, they produce a contact insecticide that competes with commercial synthetic products on effectiveness, while costing almost nothing and leaving no harmful residues. Now let me walk through the 3 specific formulas, starting with the simplest one that handles the most common garden pest problem, and often the only formula most gardeners ever need. Formula 1. Basic soap spray. This is your first line of defense, and the formula that handles 90% of common aphid and whitefly problems. It is the simplest, the fastest to mix, and the gentlest on plants and beneficial insects. If you do nothing else from this video, master this one formula. The recipe: 1 tablespoon of plain unscented liquid dish soap per 1 quart of water. For a full gallon batch, 4 tablespoons, 1/4 cup of dish soap in 1 gallon of water. Stir gently. Do not shake vigorously, because aggressive shaking creates foam that makes the spray difficult to apply evenly. You want a thin, milky liquid, not a bucket of bubbles. The water matters more than most guides mention. Use soft water or distilled water if you have hard tap water in your area. Calcium and magnesium ions in hard water react with soap to form insoluble precipitates, the white scum you sometimes see in hard water sinks. In a soap spray, that reaction reduces the effective soap concentration reaching the insects. If your tap water is hard, let it sit out overnight to dissipate chlorine, and then use collected rainwater when possible. Rainwater is naturally soft and costs nothing. Mix the batch immediately before use. Soap solutions degrade within hours, and the diluted mixture stored overnight often loses much of its effectiveness by the next morning. Make only what you will spray in a single session. Leftover spray can be poured on the base of affected plants as a soil drench. It will not harm mature plants and may help suppress soil-dwelling pests, though the effect is modest. Application technique determines whether this formula succeeds or fails. The soap must physically contact the insects. This is not a systemic treatment that circulates through the plant. Spray thoroughly on all parts of the plant where pests are present. And the critical detail is the undersides of leaves. Aphids cluster on leaf undersides and on new growth tips. Whiteflies hide on leaf undersides during the day. Spider mites colonize leaf undersides almost exclusively. If you spray only the top surfaces of leaves, you are leaving 90% of the pest population untouched. Tilt the sprayer upward. Get underneath the plant and spray up into the canopy. Coat every leaf surface top and bottom to the point of visible dripping. This takes longer than casual top spraying. It is also the difference between a treatment that works and one that fails. Plan to spend real time on each plant. A heavily infested tomato plant might take 3 to 5 minutes of thorough spraying to cover properly. Timing within the day matters. Apply in early morning before temperatures rise, or in the evening after the sun drops below 75 degrees Fahrenheit. Spraying in midday heat causes 2 problems. First, the soap solution evaporates too quickly from the leaf surface. The insects get only a brief exposure instead of the sustained contact that ensures desiccation. Second, soap residue on hot leaves in direct sunlight can cause phytotoxicity, yellow or brown burn spots that look like the plant itself was damaged. Cool leaves, cooler air, indirect or diffuse light. That is the window. Reapplication schedule. Aphids reproduce so rapidly that a single spraying rarely ends an infestation completely. New eggs hatch, new winged migrants land from neighboring gardens, and within 5 to 7 days, the population begins rebuilding. Spray every 5 to 7 days during active infestation until visible pest presence drops to near zero. For prevention on susceptible plants, young tomato starts, tender new growth on roses, the undersides of cucumber and zucchini leaves, a weekly preventive spray during peak pest season keeps populations from ever establishing. Common mistakes with soap spray. The most frequent is using too much soap, assuming that stronger equals more effective. It does not. A 4% soap solution is not twice as effective as a 2% solution. It is just twice as likely to burn your plants. Stay at 1 to 2 tablespoons per gallon. Resist the temptation to boost the concentration just to be safe. The second common mistake is using the wrong soap. Dishwasher detergent is not dish soap. It contains salts and other chemicals that damage plants. Antibacterial soaps contain additives that can harm beneficial microorganisms in the soil and on plant surfaces. Laundry detergent is formulated for fabrics and contains brighteners and enzymes that are phytotoxic. Use plain, unscented dish soap. Nothing else. The third common mistake is spraying too often. Even gentle soap spray stresses plants when applied repeatedly at short intervals. Every 5 to 7 days is the correct frequency. Daily or every other day spraying does not kill the pests faster and does damage leaf tissue progressively over time. Formula 2. Soap and oil combination. When spider mites are the problem, or when you need to treat scale insects and mealybugs, soap alone is not enough. You need the suffocation mechanism that only oil provides. This formula adds vegetable oil to the basic soap spray, creating a 2-mechanism attack that handles tougher infestations. The recipe: 1 tablespoon of plain unscented dish soap plus 1 tablespoon of vegetable oil per 1 quart of water. For a full gallon batch, 4 tablespoons of soap and 4 tablespoons of oil in 1 gallon of water. The soap acts as an emulsifier, keeping the oil suspended evenly in the water rather than separating into floating droplets. Without the soap, the oil would coat the top of the spray tank and fail to mix properly with the water below. Any neutral vegetable oil works: canola, soybean, sunflower, safflower. Avoid olive oil, which has a stronger aroma that can linger on food crops. And avoid corn oil, which is slightly more prone to phytotoxicity on sensitive leaves. For serious pest problems, neem oil sold at garden centers adds a third mechanism: azadirachtin, a naturally occurring compound that disrupts the hormonal systems of insects and reduces feeding, molting, and reproduction. Neem oil sprays are the strongest option for persistent infestations and are widely used by organic growers. The cost is higher, $15 to $20 for a bottle that lasts a season, but the effectiveness is worth it for gardeners dealing with repeated outbreaks. Stir the oil and soap into the water thoroughly before every application. Even with soap as an emulsifier, the oil will begin to separate if the mixed spray sits for more than a few minutes. Shake or stir the sprayer every few minutes during application to keep the solution uniform. Application technique is the same as basic soap spray. Thorough coverage, all leaf surfaces, undersides critical, early morning or evening, never in midday heat. But one additional caution applies specifically to oil sprays. Oil residue on leaves intensifies sunlight absorption and can cause leaf burn much more quickly than soap alone. Temperature limits for oil spray application are stricter. Do not apply when temperatures exceed 80 degrees Fahrenheit or will rise above that level within 24 hours of spraying. The oil coating needs to dry into an invisible film before the day warms up, or the combination of sunlight and oil will cook the leaf surface. Some plants are particularly sensitive to oil sprays. Young seedlings, tender new growth, and plants with fuzzy or hairy leaves can be damaged even by correctly applied oil sprays. If you are treating a new plant for the first time, test the formula on a single leaf or a small section of the plant first. Wait 24 hours. Check for leaf damage. If the test leaf shows no problems, proceed with full plant application. If you see yellowing or brown spots, dilute the formula further, 1 teaspoon of oil per quart instead of a full tablespoon, and retest. Plants that particularly benefit from oil sprays include tomatoes with spider mite infestations, squash and cucumbers with whitefly problems, and fruit trees with scale insects. For each of these, the suffocation mechanism of oil significantly improves kill rates compared to soap alone. That handles 2 of the 3 core formulas. The third adds repellent and irritant effects for tougher pest situations. And it is the one that gives your spray the power to not just kill present pests, but actively discourage new ones from colonizing the treated plants. Formula 3. Garlic and Pepper Fire Spray. This is the formula for gardeners dealing with persistent pest pressure, infestations that keep coming back no matter how many times you spray, or situations where beneficial predators are not establishing fast enough to control populations naturally. Adding garlic and hot pepper to the basic soap and oil mixture creates a spray that not only kills present pests on contact, but repels new ones from landing on treated plants for several days after application. The 2 active compounds are allicin from garlic and capsaicin from hot peppers. Allicin is produced when garlic cloves are crushed or chopped. The cell damage triggers an enzymatic reaction that converts allicin into allicin within seconds. Allicin has documented insecticidal and antimicrobial properties and acts as a contact irritant to soft-bodied insects. Capsaicin, the compound that gives hot peppers their heat, is a potent irritant to mucous membranes and sensory tissues in most invertebrates. Together, they produce a spray that soft-bodied pests actively avoid. The recipe for a garlic and pepper concentrate: peel and roughly chop 1 full bulb of garlic. Not 1 clove, the entire bulb, about 10 to 12 cloves. Add 2 to 3 fresh hot peppers, jalapenos, cayenne, Thai chilies, or any hot variety you have. For convenience, 2 tablespoons of dried cayenne pepper or red pepper flakes substitutes effectively if fresh peppers are unavailable. Combine the garlic and peppers in a blender with 2 cups of water. Blend on high for 1 to 2 minutes until the mixture is thoroughly pulped. Let this concentrate steep for 12 to 24 hours at room temperature. Steeping allows the active compounds to fully extract into the water, strain through cheesecloth or a fine mesh strainer into a clean container, pressing the solids to extract as much liquid as possible. What remains is your garlic and pepper concentrate, enough for 5 to 6 batches of finished spray. To make the finished spray, combine 2 to 3 tablespoons of garlic and pepper, concentrate with 1 tablespoon of dish soap, and 1 tablespoon of vegetable oil in 1 gallon of water. Stir thoroughly. The soap and oil deliver the contact kill effect. The garlic and pepper add repellent and irritant action that extends the protective window after application. Safety precautions for handling the concentrate. Capsaicin is a serious irritant. Wear gloves during preparation. Do not touch your eyes, nose, or face during or after mixing. Work in a well-ventilated area. The fumes from fresh hot pepper in a blender are surprisingly strong and can cause respiratory irritation in enclosed spaces. Wash the blender, cutting board, and all utensils thoroughly with soap and water when finished. The concentrate is harmless to plants at the correct dilution, but extremely unpleasant if it contacts human mucous membranes directly. Store leftover concentrate in a sealed glass jar in the refrigerator for up to 2 weeks. After that, discard any remaining portion and make a fresh batch. The active compounds degrade over time, especially when exposed to light and warmth. Application of the fire spray follows the same protocols as the previous formulas. Thorough coverage top and bottom of leaves, early morning or evening only, never in midday heat. The garlic and pepper residue remains active on leaf surfaces for 3 to 5 days after application, providing repellent effect between sprayings. Reapply every 5 to 7 days during active infestation. One additional caution specific to the fire spray: do not apply within 3 days of planned vegetable harvest. The garlic and pepper residue, while completely safe, can leave a faint flavor on harvested produce, particularly on leafy greens and soft-skinned fruits like tomatoes. Rinse harvested vegetables well if they have been sprayed within the previous week. Alcohol spot treatment for mealybugs and stubborn infestations. One additional technique worth covering because it handles situations where sprays alone are not enough. Mealybugs. Those tiny white cottony insects that cluster in leaf joints and stem crotches. And heavy scale infestations often require physical removal combined with a fast-acting contact kill. Rubbing alcohol at 70% concentration, applied with a cotton swab directly to each visible insect, kills on contact by dissolving the waxy protective coating and desiccating the insect instantly. Dip a cotton swab in 70% isopropyl alcohol and dab each mealybug or scale insect you can see. The insect will discolor and detach within seconds. Work through the plant systematically, checking leaf joints, stem bases, and the undersides of leaves where these pests congregate. Follow the alcohol treatment with a normal soap and oil spray 2 days later to catch any eggs or young that survive the direct treatment. Alcohol spot treatment is time-consuming, but extraordinarily effective for small infestations or isolated pockets of stubborn pests. It is also completely safe for the plant at the target application rate. The alcohol evaporates within seconds of contact and leaves no residue. Protecting beneficial insects. Here is a subject that most DIY pesticide guides ignore completely, and ignoring it is how gardeners turn a minor pest problem into a major ecological disaster in their own backyards. The soap, oil, garlic, and pepper sprays we have been discussing are not selective. They kill soft-bodied insects on contact. That includes aphids, and also includes ladybug larvae, lacewing larvae, hoverfly larvae, and the immature stages of almost every beneficial predator that naturally controls garden pests when you let them. If you spray indiscriminately every week throughout the growing season, you create a garden where pests recover faster than beneficials because beneficials reproduce more slowly and are more vulnerable to non-selective treatments. The result is a pest control treadmill. You spray, pests die, beneficials die, pests rebound first because they reproduce faster. You spray again, and the cycle never stops. Your garden becomes dependent on weekly human intervention because the natural control systems have been destroyed. The smarter approach is targeted spraying. Treat the specific plants and specific areas where pest populations have exceeded acceptable levels. Leave other areas of the garden alone to serve as refuges for beneficial insects. When you see ladybugs on a plant, do not spray that plant. Ladybugs will eat significant numbers of aphids in a few days, often resolving the problem without chemical intervention at all. When you see lacewing larvae, tiny alligator-shaped predators with prominent jaws, leave them alone and watch the pest population collapse around them. Apply sprays in late evening when pollinators have returned to their nests. Bees, butterflies, and beneficial flies are generally inactive after sunset. A spray applied at dusk has 12 hours to dry and dissipate before pollinator activity resumes the next morning. This timing protects the pollinators your garden needs for fruit and vegetable production, while still delivering full contact kill on pests that remain on the sprayed plants. Never spray blooming flowers directly. Pollinators visiting flowers for nectar will receive direct exposure to the spray, killing them outright. If a pest problem requires treating a flowering plant, spray the foliage below the flower zone and leave the blooms themselves untreated. If pests are concentrated on the flowers, consider whether the infestation is actually severe enough to justify treatment. Often flower-focused pests are transient and resolve themselves within a week. Attract beneficial insects actively by planting flowers that support them. Dill, fennel, yarrow, sweet alyssum, and zinnias draw ladybugs, lacewings, hoverflies, and parasitic wasps. A garden that contains these plants maintains its own pest control workforce and requires less spraying overall. The DIY sprays in this video should be a supplementary tool, not the primary control mechanism. The primary mechanism should be a diverse, balanced garden ecosystem, where natural predators keep pest populations from reaching damaging levels in the first place. That is the full spray toolkit. 3 formulas, 1 spot treatment technique, and a framework for applying them without collateral damage. Now let me walk through the complete application protocol. When to spray what, for which pest, on which crops, and the practical details that turn these formulas into a working pest management system. Let me walk through the complete application system. When to use which formula, for which pest, on which crops, and what to realistically expect in the first week of treatment. For aphid infestations on vegetables, herbs, and ornamentals, start with Formula 1, basic soap spray. Spray every 5 to 7 days until aphid populations visibly crash. Most soft-bodied aphid colonies respond within 2 applications. Focus coverage on new growth tips and leaf undersides where aphids concentrate. For heavy infestations that do not respond to 2 weeks of soap spray alone, escalate to Formula 3, the garlic and pepper fire spray, which adds repellent action that prevents winged aphids from recolonizing treated plants. For spider mites on cucumbers, squash, tomatoes, beans, and ornamentals, start with Formula 2, soap and oil combination. Spider mites specifically require the suffocation mechanism that oil provides, because their egg stage resists soap alone. Spray every 5 days for 3 consecutive applications to cover the full spider mite life cycle from egg to adult. Focus coverage on leaf undersides and along major leaf veins where mites travel. For severe mite outbreaks on cucurbits, substitute neem oil for vegetable oil in Formula 2. The azadirachtin adds hormonal disruption to the suffocation effect and produces dramatically better results on established mite populations. For whiteflies on tomatoes, peppers, eggplants, cucumbers, and brassicas, start with Formula 2, soap and oil combination. Whiteflies are particularly challenging because adults fly off the plant the moment you disturb the foliage, making direct contact kill difficult. The trick is to approach the plant slowly, spray from below while adults are still settled on leaf undersides, and catch as many in the initial spray as possible. Spray every 5 days for 3 to 4 consecutive applications. Yellow, sticky traps placed near affected plants capture adult whiteflies between sprayings and significantly speed up population collapse. For mealybugs and scale insects on fruit bushes, herbs, and ornamentals, combine alcohol spot treatment with Formula 2 soap and oil spray. Use the alcohol-dipped cotton swab to kill visible adults directly. Then spray the entire plant with the soap and oil combination to catch eggs and juveniles. Repeat every 7 days for 3 cycles. Persistent infestations in enclosed spaces, greenhouses, indoor plants, sometimes require 4 to 5 treatment cycles to fully eliminate. For thrips on onions, beans, roses, and ornamentals, use Formula 2 soap and oil combination. Thrips are harder to kill than aphids because they can hide in protected parts of the plant, inside flower buds, between emerging leaves under bud scales. Thorough coverage is especially important. Spray every 5 days for 3 applications, and consider adding blue sticky traps to monitor adult activity between sprays. For flea beetles on brassicas, eggplants, and potatoes, soap and oil sprays have limited effect because flea beetles have hardened outer shells that resist the desiccation mechanism. For flea beetles, Formula 3 garlic and pepper fire spray is more effective because the irritant and repellent action discourages feeding and egg laying. Also consider physical barriers like row covers during peak flea beetle activity, which is often more effective than any spray. For cabbage worms, tomato hornworms, and other caterpillars, none of the formulas in this video are particularly effective against caterpillars. For caterpillar problems, Bacillus thuringiensis, sold as BT, a naturally occurring bacterial insecticide, is the correct organic solution. Hand-picking also works and is genuinely practical for home gardens where caterpillar populations are usually small enough to manage manually. Realistic expectations for the first week of treatment. Day 1. You spray thoroughly using the correct formula for your pest. Within minutes, you can sometimes see aphids visibly shriveling on contact with soap spray. The kill mechanism is fast on soft-bodied insects. Whiteflies and spider mites die more slowly, but still within hours of adequate coverage. Day 2. Check the treated plants. Dead insects should be visible. Shriveled aphid bodies still clinging to leaves. Motionless whiteflies on undersides. Spider mite populations reduced to small, scattered survivors instead of large colonies. The plants themselves should look normal. If you see yellow or brown leaf damage, your concentration was too high or you sprayed in excessive heat. Reduce concentrations next application, days 3 through 5. Surviving insects and newly hatched juveniles begin repopulating if the pest source was not fully eliminated. This is normal. A second application on day 5 to 7 catches this secondary wave before it establishes into another full infestation. Days 7 through 14, 2 complete spray cycles should reduce pest populations to levels that are barely noticeable. New pest pressure from neighboring areas may still introduce fresh migrants, but established infestations should be effectively under control. At this point, shift to a weekly preventive spray schedule rather than active treatment. Week 3 and beyond, once populations are controlled, preventive spraying can often drop to every 10 to 14 days. Monitor affected plants closely and return to weekly spraying if pest populations begin rising again. When DIY sprays are not enough, honesty matters here. These formulas are effective against the most common soft-bodied garden pests, but they are not a complete pest management solution for every situation. Certain pest problems require additional tools. Heavy-scale infestations on established fruit trees often require dormant season horticultural oil applications. Spraying during winter when the tree is leafless to smother overwintering scale under a heavier oil concentration than would be safe during the growing season. This is a commercial approach that home gardeners can adopt using bottled horticultural oil from any garden center. Major outbreaks in commercial-scale operations or severely infested plants may justify stepping up to organic-approved commercial products. Insecticidal soaps sold in bottles at garden centers are concentrated and standardized versions of the Formula 1 recipe. Commercial neem oil products offer better emulsification and consistency than home mixed oil spray. Products containing spinosad, a natural compound derived from soil bacteria, work well against caterpillars, thrips, and leaf miners, where DIY formulas fall short. None of these commercial products is unreasonable. All are considered organic approved. For severe situations beyond what homemade sprays can handle, they are the appropriate next step. Ant partnerships with aphids require separate treatment. If ants are actively farming aphids for honeydew on your plants, spraying the aphids without addressing the ants results in the ants repopulating the aphid colonies faster than you can kill them. Apply a band of diatomaceous earth or a sticky barrier around the base of affected plants to interrupt the ant traffic. Then spray the aphids. Breaking the ant-aphid partnership is often what finally ends a persistent aphid problem. Preventive garden practices that reduce spraying need. The best pest control is a garden that supports natural predators strongly enough that outbreaks never reach damaging levels. Plant flowering herbs and flowers. Dill, fennel, cilantro allowed to bolt, yarrow, sweet alyssum, cosmos, zinnias that attract ladybugs, lacewings, hoverflies, and parasitic wasps. Avoid broad-spectrum insecticides that kill pests and predators indiscriminately, including overuse of even homemade soap sprays. Rotate crops between seasons to disrupt pest life cycles that overwinter in soil. Remove weeds along garden borders where pest populations build up before migrating into your crops. Healthy plants resist pests better than stressed plants, so focus on strong soil, consistent watering, and appropriate fertilization to keep your crops vigorous. The full toolkit. Soap spray for aphids and general pest control. Soap and oil spray for spider mites, whiteflies, and scale. Garlic and pepper fire spray for persistent infestations and repellent effect. Alcohol spot treatment for stubborn mealybugs. Sticky traps, diatomaceous earth, row covers, beneficial insect habitat, and organic approved commercial products for situations that exceed DIY capacity. 4 ingredients from your kitchen. 3 formulas. A pest control system that costs under $1 per gallon of spray. No synthetic chemicals, no residues on your food. No harm to the pollinators and predators your garden depends on. And plants that reach harvest season intact instead of half destroyed by pest damage you could not figure out how to stop. If this changed how you think about protecting your garden without reaching for synthetic pesticides, type GROW in the comments and hit the like button. It helps this video reach gardeners who are still watching their crops disappear under aphids and mites because they do not know what is already sitting in their kitchen. And if you are not subscribed to the Amish Secret to Gardening yet, this is your invitation. Practical methods, real science, 0 products to sell. Hit subscribe, turn on notifications, and we will see you in the next one.